I'm Eric Siegel, CEO and co-founder of Gooder AI. This is the third of several short how-to hands-on videos that'll get you started using Gooder AI to evaluate your ML models and plan ML deployment to achieve maximal business value. All the supporting documents and links you need to follow along and try it yourself are at gooder.ai/hands-on. In the previous video, we've covered the data requirements, scored test data, how to get started evaluating models with Gooder, and also how to do so from within Python for scikit-learn and XGBoost models. In this video, we'll cover several options to adjust how the main business value metric, that is the y-coordinate of this chart, some of the other metrics, and really any chart or metric in the table, be it profit, earnings, or savings, is calculated. That is, selecting among options for how the potential value of your models is estimated over the test examples, depending on how you plan on deploying, that is, the particulars of your project. So among these getting started videos, this is the one that's the most meaty as far as being impactful on configuration options in Gooder. But as you'll see, this video will also set the stage for a very surprising, cool, impactful revelation about predictive analytics projects in general, with or without Gooder, which will be covered in the next video after this one. Spoiler alert, it'll be about driving decisions with the estimated value rather than the usual practice of driving decisions with the raw model score probabilities. Okay, so we're starting from where we were in the last video. Remember, we had made a random forest and 2 XGBoost models and then invoked Gooder from within a notebook, but that doesn't really matter at this point. We could have just as well created the models with any ML tool and gotten here by loading the test data file into Gooder as shown in the very first video. So one adjustment I really should make is that we've got this slider here set 500. We had played with it a little bit, but the idea there being is that if fraud goes undetected, it's costing us 500, which translates into a savings of 500 on average when fraud is correctly detected, right? So it's adding to the savings. But in any case, 500 is sort of a general, at least apocryphal industry standard for credit card transactions. But with this particular data set from Kaggle, as we covered previously, it's actually only 135 dollars per transaction if we assume the fraudulent transactions are within that realm. So now we're more in ballpark. That means we're not losing as much with fraud with this particular arena, this ballpark. That's what the test data always should represent. Whether you're evaluating or more specifically evaluating with Gooder, it's got to represent the universe in which we're operating that we care about, and that's what we're doing. In this particular one, let's zoom in because you're only going to block at most a few percent of potentially fraudulent payment card transactions. But now we're peaking around up to below 25 million rather than what we had before, which was 100 million. So that's because, we don't stand to lose as much with fraud, which means we don't stand to gain as much with fraud detection. Penny saved is a penny earned. Anyway, starting from here, a little bit more realistic setting with regard to this data. We're using, as we got into last time, we're using the default monetary metric, which was called profit originally, right? But you're reframing it, sort of what's that monetary, what's the gains, what's the winning, the earnings. Really the word savings may be the best one. That's why we've got the word savings here and here and here for fraud detection, because fraud is costly and either way it's a win, right? It's improvement to the bottom line. Penny saved is a penny earned. But we aren't satisfied right now because it's a little too simplistic the way that it kind of roughly estimates, since it's just based on this flat amount that you save per correctly identified fraud, 135 or whatever you set this to. Rather, it should be calculating, since it's testing across a bunch of transactions, we have the size of each transaction, the magnitude, it's a $100 transaction, a $5,000 transaction. Let's use those numbers so that when we correctly identify fraud, we're gonna win accordingly. Like let's roll up the savings in using that data. We have it, so why not use it? So the starter config file that we covered how to access, includes a bunch of sort of standard setups for this main metric, right? As well as some other ones, some of which are shown here. So let's go into the config, and we're going to turn on we're going to swap in a different one. So just briefly, the config has 3 main tabs. This is global, which means it's sort of general settings that pertain to all the charts and metrics and stuff that you're looking at on the canvas. The second one we'll come back to in a minute, but that's when you're looking at particular charts, widgets, metrics. Those are basically synonymous in this context. We're looking at one and how are we setting it up for that one chart or that one row in the table. But then the widget selector is among those which ones are showing on the canvas on the main home page there, right? And here we have a list of all the ones that are included in the standard config setup. Other ones can be made, more specialized ones. But you see here, we had changed the name of the default one, the first one, profit curve A. We say to change it to savings. But we also have profit curves B through I. And we're going to change it to B, and then do a little more setup on it, and then see what that looks like. As you can see here, for every single one of the options that are built into this config, you can, with these 2 columns, you can decide which ones show as a chart and or in the table. So all metrics or dashboards, all metrics or widgets or metrics, whatever you want to call them, are always calculated across the spectrum of decision boundary potential. That's why they can appear as a chart, in 2 dimensions, or appear one data point in the table depending on where you've moved that decision boundary. So you can decide for each one whether to show one place and or the other. As you can see, most of them are off, which is typically going to be the case. You're just sort of picking and choosing for the particular project. So let's change to profit curve B, and that's going to incorporate the amount of the transaction. So let's turn the other one off. We're going to swap it in. We're going to click this button, which, on the canvas, you can move the charts around and resize them and stuff. But let's just click this just to put it right up at the top. And then also we'll put this flag on down here, which makes everything on the canvas shift up to eat any unused white space. But before we go to the canvas, the main home page with this home button, let's go actually make a couple quick configuration changes to that profit curve B that we just turned on there. And here's what we're going to do. We're going to once again rename it to savings. We'll call it savings 2 as a matter of course, and call the metric, which is how it appears in the table. Also call that savings. And then we'll be able to see this a lot more clearly when we go to the main page. And then we're going to change some of the nomenclature again to be in alignment with this particular use case of fraud detection. We're going to change the first slider, which is basically the false negative cost, that is to say true positive gain. Pretty much the same thing, the cost of fraud or the gain of fraud detection, right? Let's call it cost of undetected fraud, because the names that are built in here with the starter config are very generic, and they're not particular to any project or use case. And then likewise, we've already made sort of a change to the second one, because this chart is using the same second slider, so that name's already been changed. But let's change it a little bit so we know it's dollars. It's still going to be flat rather than based on a flat amount based on the magnitude of the transaction. And then last but not least, we have to tell the setup for this metric we have to point it to the correct field in our data, the correct variable that corresponds to amount, the amount of the transaction. So this word amount is the label given when this particular metric was set up. So it's saying, hey, you need to select something to correspond to amount. And so you see here, these are the columns in that data set, the variables, and obviously it's transaction amount. So we set it to transaction amount, and it's going to use those values in the calculation. You have to tell it that, right? I mean, we've already told it which of the models and which is the dependent variable, but now it's using another variable, which may or may not have been an independent variable for the model. Either way, we have that value. We need to incorporate it, but we need to tell Gooder, which one it is. So now we've done all that. Now we update that current chart at the bottom. There's a bunch of other settings, but we're not covering all those today. And now we have successfully swapped in a different version of the savings curve that's based on a percentage of the actual transaction amount, set to 100% right now. The rest is all the same. So we've swapped that in. And let's put on our business hats and talk about the meaning of this chart with regard to the current project, which is payment card fraud detection. Once again, we should probably zoom in. We're only going to block at most 1 to maybe 3%, probably less than that, of payment card transactions. So zoom in where it matters. You see 3 models, and the shapes of the curves are just going to be intrinsically different. It's calculating it differently. It's calculating in a more precise way. Now let me tell you what this first slider means. The second one's still the same. So it's the cost of a false positive, inconveniencing a legitimate transactor, or a transaction that gets blocked even though it was actually legitimate, right? So you've annoyed the cardholder or inconvenienced them, and we have that still set to a flat amount. I'll come back to that in a minute and play with that. This one is the percent. So we're currently set to 100%, meaning that if a transaction that's fraudulent, that's for $200, and we've correctly labeled it as fraud and blocked it, that is to say it belonged on the left side of this decision boundary, right? So again, we're ordering from left to right, most likely to be fraud down the least likely. The decision boundary is deciding which individual cases, in this case transactions, get treated, in this case that means blocked automatically and not authorized. All those in the top echelon, the most risky, that is to say everything to the left of the decision boundary, are going to be the ones that are considered positive cases, fraud, and therefore be treated, in this case they'll be handled by blocking them. That means everything to the left is a positive case, either a false positive or a true positive, and these two correspond to the value you get from either correctly or incorrectly identifying. So every time you have a true positive, that is the things to the left that actually were fraud, we've saved 100% of the transaction. That presupposes that if we didn't catch it, it would have cost us or the bank 100%. But if you have a $500 transaction that's fraudulent, that doesn't always mean the bank's necessarily going to lose exactly $500. It may be less. They may only lose 90, 85%. It depends on a bunch of factors. There could be insurance covering certain kinds of fraud. There could be a recoup effort, sometimes enforcement downstream where some proportion of fraud actually does get recouped. Whatever it is, the point is that these kinds of things are subject to some uncertainty and or change. And that's why we want to parameterize them and be able to say, well, how big a difference does that make, right? In the case of fraud actually only being sort of 85% as expensive per case based on the size of the transaction, that means that's good news if that's the case for your bank. That means fraud doesn't cost as much, but it also means you don't stand to save as much with fraud detection. So that's why when we move from 100 down to 85, the curve kind of goes down, the peak of the curve, the magnitude, the monetary gain of fraud detection goes down just because the smaller opportunity fraud's not costing as much. But we want to make things as realistic and closely aligned with business reality as possible. And then at the same time, we want to be able to play with these sliders because to the degree things are subject to change or uncertainty, we want to get that intuitive sense of how big a difference it makes. So if nothing else, this is a interactive data visualization solution, which is necessary because we have these kinds of parameters we can configure setup that are subject to change and uncertainty. We want to know how big a difference they make in terms of our estimation, our forecast of the value of deployment, so we can make an informed decision. And let's go through the same concept. We're going to the second slider, which here is a flat cost of how much does it cost every time we inconvenience. That is a false positive. Everything to the left of the decision boundary, that is the case is treated as fraud, but actually we're not fraud. Those are false positive. Cost of wrongly blocking, $75. Well, think about it. What if we as a bank, we're going to be like, look, every time we cause that inconvenience to a cardholder, we're going to send them an apology and a $10 Amazon gift card or something like that. That's going to be costly, but on average, it may actually mean that the net cost of false positive goes down to $50 or this kind of thing. Or maybe we don't know because we haven't tested it. But what if it did? Would it be worthwhile? Is it even worth that? How big a difference? How much does it change the story? The story is the shape of the curve. The story is where the peak lies horizontally and the magnitude of the peak, right? So whatever it is, we need to be able to interact, get that intuitive sense. It's going to help inform decisions about where there's uncertainty, whether we should collect more data to lower the uncertainty, how comfortable are we with the current estimates so that we can move forward with an deployment decisions that are informed by business factors, such as the monetary value of the model, right? That's the whole purpose here. And that's the thing that's usually missing. People don't estimate that monetary value of the model. So once again, we have something I covered in the last video, but we're seeing right here, well, let's go to the proper peak. So I go to the maximum value. That's right here. And it's saying that with the best model, we would stand, if this is over 10 million transactions a quarter, that means we would stand to save $21.5 million a quarter estimated. But in so doing, we would be incurring this many false positives a quarter, 51.7 thousand. So the curve is a little bit flat here. So we could go, instead of 21 million, we could go down to 20 million to some sacrifice in the estimated savings. And boy, we just cut the number of inconvenienced customers and all the sort of intangible value of avoiding that in half, down to 25,000 a quarter. So it is half, right? Am I remembering correctly? Let's go back to the top. Yeah, we went from 51 down to 25. So that's great. And again, that's the point. We need to be able to look at these kinds of curves. Okay, great. So now just one last thing before we end this video. I want to put a little context in how we moved from profit curve 1, where we had two fixed values. These sliders correspond to fixed dollar amounts for corresponding to basically false negative and false positive costs. And now we have one that's based on the actual transaction, a percent thereof for the false negative, or that is a true positive gain. One person's false negative cost is another person's true positive gain, because penny saved is penny earned. In any case, here, oh, sorry, wrong button. So let me bring up that file. Here we have, this is a PDF that's available. Again, everything's available at gooder.ai/hands-on. This document is the standard earnings curves that are available, and you see there's a list of 9 of them. These are the ones, profit curves A through I, that are available in that standard starter config setup for Gooder. And they cover a good majority of at least strong first pass configurations, depending on your particular use case and project across sectors, right? So this could be for fraud detection, targeting, marketing, predictive maintenance, all different kinds of risk management. And the last 3 are specialized in marketing, specifically for churn modeling, but they're actually sort of just variations with a third slider you added. So let me just talk through the first 3, and then the rest kind of become obvious, just to give you a sense, depending on your project, how you might pick and choose between these. Basically, they vary by the second and third column here, which is whether that true positive gain and false positive cost, those sliders, whether they are fixed amounts as they are in the standard profit curve A setup, right? Which is the default setup, which kind of makes sense, right? If all you have to do is tell Gooder which is the dependent variable in which of the models, or if you came from Python, scikit-learn XGBoost, you didn't have to tell it that at all, because it made the scored test data. But you're gonna at some point have to tell it which column, which variable is the amount, the magnitude of the transaction, the amount of revenue you've been getting from a customer that might defect if you're doing churn modeling, right? There's all different, or how deep the pockets are of a prospective donor for soliciting donations. There's all sorts of places where you want to incorporate that amount, and you have to tell the software, Gooder AI, which variable it is where you have these shaded ones. I'm colorblind, but I think these are light blue. And those are the ones where you have one or both are based on a percentage. So we moved from A to B just now, and we had that percentage. So we had to specify that or the chart wasn't going to work. So any ones that are shaded corresponds to this note down here saying you have to specify it. So we moved to B where we had the true positive gain, that is the same as false negative cost, letting fraud go through, for example, that as a percentage. But you can also have them both as a percentage, right? So for example, if you're doing churn modeling and you're considering targeting a retention discount, well, the percent discount, let's say you're giving a 20% discount or you're considering giving a 15 or 20% discount, that's going to come off the revenue you're getting from that particular customer if they're a false positive. You predict they churn, but they're not there. We're going to stay anyway. They can consume your discounts, so the cost to you of the discount depends on the magnitude. So that's why sometimes you'd also want the second slider to also be a percentage, in which case you go to profit curve C. The next three, D, E, and F, follow the same variations. The difference is in when the false positive cost applies. So the false positive cost, you can consider it the cost of targeting, of contact for marketing. So let's say you're sending a brochure, costs $2 to contact each person, or maybe you're going to vary it, move to black and white, so you want to be able to vary it. But whatever it is, it's the cost to contact. But but the benefit, the upside, the win when they actually respond to your marketing, right? Is that value after you subtracted? You're still contacting them as well. So should that amount that you're taking off apply for all cases or only for the false positives? Of course, if it's all cases, technically speaking, it's not a false positive cost. It's just in every case that's treated cost. So it would count for everything up to the decision boundary. So it's a relatively small change, but I just want to make the arithmetic more accurate. So that should be enough to get you started trying out these different variations that are built in a standard configuration setup. But I should also say that there's plenty of cases where you're going to want to potentially go beyond this. You're going to want to add additional sliders. You're going to want to incorporate, instead of just true positive and false positive, you might want to incorporate, we've had cases where true negative and false negative, those are the ones to the right side of the decision boundary, need to be incorporated. So there's it's fully configurable. Gooder is ready for any and all of those kinds of variations and setups. It's just they take a little bit more advanced user under the hood. You can actually play with a JavaScript snippet within the configuration for each of those widgets, each of those metrics. So if you're interested or feel a need to go beyond what's capable here and have a bit more customized of a configuration, then reach out to us. Go to gooder.ai/hands-on and go to the bottom. You'll see there's a user support form. So reach out to us. Feel free to ask any questions. I think that's all I wanted to cover for this video. Again, in the next video, we're going to take this and run with it. We're working with the amount of the transaction, but we're only deciding, ordering, and thresholding based on the probability that it's fraud. What about the magnitude? Shouldn't that also be part of our decision of whether to block it? That's what we're going to do. You're going to be like, wow, we're going to do that in the next video. So please stay tuned.